Hey, Dan joined.
Hi, Dan. Hi.
Hey, my audio is working great. Good, good to hear from you again, Z.
Yeah, me the same. Yeah, me the same. Yeah.
Hey, morning, Dan.
Hey, good morning. Morning, Dan, as well. Maybe my camera works. Let me see. It does.
Good morning, everyone. My name is Jean-Max. I'm a newcomer.
Oh, okay. Yeah.
Nice.
I think you're the only new name. Let's start off with a quick intro from you. So in the past, we've gone around and people that want to participate in the conversation, we just ask them name and role and their interest in
Sure.
participating.
My name is Jean-Max. I work at Anjuna Security, which is a company who's doing a lot of tooling around confidential computing for enterprise companies. And my role is I'm a lead architect on everything related to confidential computing.
Okay, cool. Welcome.
Thank you.
So we're getting started here. Maybe I will flash up the slides we talked about last time, and maybe also do a quick level set for new folks about what we're doing in this forum. That looks horrible. Let's see.
It works.
It works now.
Okay, we only see the top left corner. Okay, that's good.
It's better? Okay, perfect. So this is February because we ran out of time last time. I'm going to start with this one before we get into the new topics. But welcome to our new digs. This is a call that was born out of realization that we needed to have much more frequent contact to get through kind of the backlog of issues around all of the difficulties, well, the challenges of supporting device security. We're calling it device security instead of trusted I/O because the trust word makes things devolve into an argument about where the trust boundary is. So all we're talking about here is allowing devices to access private memory and all of the mechanisms around that. It started as an Intel hosted call. Along the way, we realized that this collaboration is really useful, and there's more than just device security topics to eventually talk about. And so Dan Middleton suggested, hey, why don't we create a kernel SIG inside the Computational Computing Consortium? And I thought that was a great idea. And so now the good thing is we have Linux Foundation meeting infrastructure support for this meeting going forward. One of the implications of that is that these meetings are now recorded and the recordings are posted on YouTube, which is good for people where this is not a good time slot. They can review those transcripts, but it bears reiterating that it was always the case that this was an open source call, and everything that was said in this forum was suitable to be also repeated on the mailing list, but now it actually is going to be repeated on a public recording. So be aware of that. This is also not a decision-making body. This is just a forum to build consensus via voice, and it's to supplement building consensus via emails to the mailing list. But like all other Linux kernel decisions, the final decision is going to be made on the mailing list, and with patches and patch review, we're not going to kind of talk our way through it. It will eventually be on the mailing list. I don't know if I can mute people. Gobi, can you mute? Thanks. Yeah. So the nice thing about the recordings also is the transcripts are searchable on YouTube, which I think is really useful. If people hear a magic word, they can go search it on the transcript and jump to the point of the call that talked about it. So that's useful. Okay, so we did one introduction from Jean-Max, and I wanted to give an opportunity for others to, if you haven't been to one of these calls before, go ahead and I'm also new to using Teams. Is there a raise hand button in this thing? Probably not. Like
It's Zoom.
It's Zoom. Yeah, it's not Teams anymore. So, well, we will have to. Yeah, go ahead, Liam.
Eric. I'm based in Ireland and I'm working for Oracle. I've just joined in on this.
Okay, and what's your main interest in around computational computing?
Mainly on the kernel side of things, just
okay.
distro kernels and general development.
Kernel general. Okay, perfect. Yeah, yeah. I will say that that the next, for the foreseeable future, these calls are going to be pretty heavily focused on. Oh, there's a hand raise thing. Are going to be pretty heavily focused on this device security, bringing devices to access private memory into the trust boundary. But yeah, eventually we also want to morph this into wider kernel topics. Anyone else want to do an intro?
I'm attending this one for the first time, but I attended the LPC discussions that had happened some months back, and my interest is obviously from the RISC-V perspective, and we've been working on confidential computing architecture for RISC-V under the RISC-V International group, right? And there's technical work groups there for what we call confidential VM extensions, or CO, and that's something we've been discussing. There's a co-IO aspects that I think Samuel and others have been contributing and discussing in this list already. So I think you're kind of familiar with that, but that's sort of the spec that's being discussed in RVI. Right? There's a co-VBI and a co-IO ABI.
Okay. Good to hear from you again, Robbie.
Yep.
Okay.
Do we have intros ongoing? I joined a bit late. I had some.
Yeah. Go ahead.
So hey everyone. My name is Mikko, and from Intel, Mikko Ylinen. Newcomer in this meeting, working with Dan on confidential computing, confidential container related topics, but most recently I've been following some of the runtime measurements and event logging related topics. So that's my main interest for this group going forward.
Yeah. Good to meet you, fellow colleague. Okay, last call for intros for people that are new to the meeting. Okay, so last time I did a quick review of where we were at with respect to what had talked about at Plumbers. Given the new people joining, I thought I'd kind of review these guiding principles one more time. The goal here is, well, one is the realization that this is actually a very opportune time that we have multiple host vendors all kind of showing their cards at the same time, and trying to get all these technologies supported upstream in Linux. And the benefit of that is we can all collaborate and build the commons. The challenge is finding a way to do that in a way that doesn't stress out the upstream kernel community, because they kind of want to review something. I mean, I'm an upstream subsystem maintainer myself, and I'd love to review something once and have it apply to multiple vendors all at once, and not have to really dig into the details on each vendor's idiosyncrasies. So one of the kind of the guiding principles we came out of Plumbers with was we want to look at these architectures and kind of find the coarsest grained interface to Linux, basically the one that the design that exports the minimal amount of complexity to Linux without having to totally rewrite the world. Like one of the feedbacks from Plumbers that was kind of that kind of set the stakes was basically if we end up complicating Linux and arguing amongst ourselves too much, like one of the senior maintainers was like, why don't we just push everything down behind EFI and like just work with EFI to build a common cross-vendor software interface and stop trying to enable all these different vendors. I don't think we're close to tripping into that space, but those are kind of the stakes of Linux has the patience and the ability to wait for things to get cleaner. And so I think our job here is to we're gonna walk hand in hand and agree on some common infrastructure and make things easy for upstream to ingest. The other aspect of this conversation is to try to identify the most ruthlessly simple implementation first, but no simpler, but enough to get foundational pieces upstream that may not support 100% of the use cases, but maybe they support 80% of the use cases, and then we'll fill in on the back end with the 20%. Because as I've gone through this, and probably others have seen this too, like there's a lot of use cases, a lot of corner cases, a lot of features that people are concerned about, and some of those are probably wait, and some of those for the kind of the next phase after the introduction, and some are so fundamental that they need to be first. One of kind of the overarching themes we've identified is that we want to be prepared for error handling. We want to have the ability to, after you've assigned the device and got it into private mode, if for some reason it falls out of private memory access mode, that there's mechanisms to recover that and bring it together without bringing down the entire VM. And to date, all of kind of the I call them expert flows or feature additions have kind of fall into that error handling bucket. Like, how do we trigger all these complex flows from guest side stimulus? And so to date, I haven't come across a feature request that hasn't really fallen into that error handling bucket. So those are the guiding principles of what we're doing here. And also feel free at any time to raise hand and have a discussion. Today I wanted to kind of continue the exploration of this RFC I sent out. And this RFC was around reconciling 3 different implementations of device security or TIO. There's the SEV TIO proof of concept tree that's public. Alexei maintains that. It has kind of the end-to-end flow there. There's a similar tree to that that Intel has internally that's mainly been more for harder validation, but it's a similar level of implementation. And then we also have, and I'm glad Lucas is here, Lucas has been working on the native CMA support for Linux. So this is the ability for Linux to authenticate devices itself. And so there's these three I wouldn't say complementary, but also wouldn't say competing. The co-opetition approaches that we kind of need to gel into one kind of upstream framework, and that's what this RFC was about, was enlightening the PCI core to extend what it's going to get from CMA, from Lucas's patches, and start to take that just authentication step and take it further to connecting to the platform TSM. That's what we're calling it. The TSM is a term that's all over the PCIe spec. This is the host side agent that is talking the TDIS protocol to a device DSM. This is that naming split is I think it's critical to understand. Like we've had discussions about should this be called the TDISP layer, and if you look at going back to that whole the principle of the coarsest grained interface is kind of what we want to talk about for Linux. The coarsest grained concept is you connect a device to its TSM, and the TSM handles whether you need IDE or not, what is talking to the device. Technically, it doesn't even need to talk TDISP. Like, as far as Linux is concerned, it just connects to a device and binds it later. So these are the generic verbs: connect and bind, and the details are a lot of the details are abstracted by the TSM. Sometimes some of the TDISP things leak through because things like interface reports and other data structures that are defined by TDISP. But for the most part, there's a host side of this and a device side, and Linux talks to the host side. But the main thing I want to talk about today was kind of sharing a discussion that Lucas and I have been having this week, and just going through some of the feedback I've received on this core integration piece. So the version that's out there now, is getting long on the tooth. I'm getting ready to refresh it. The main feedback, the main concern raised by Alexei was like, do we really need to do this in the PCI core? Shouldn't this all be 100% modular? And my main concern about being in the PCI core is integration with not only the native CMA implementation, so that we have a common idea of authenticated. Lucas, go ahead, actually.
Yeah, so in the past, these PCIe port service drivers were indeed modular. And at some point, Bjorn decided to remove the ability to make them modular. So they are now declared bool, and you can decide only at compile time whether you want them or not. So that's really a conscious decision by Bjorn that these things are not modular, and I don't see a way around that. I don't see a way of convincing Bjorn to change his mind about that. So that's really something that we need to live with. I mean, Alexei can complain about it, but that's not going to change Bjorn's mind. He really wants those features baked into the PCI core and be bool and not tri-state.
Yeah, and I also think that thank you for that history. But yeah, I mean, and for the rest of the group, I really look to Lucas as kind of my Bjorn whisperer. Like he's their relationship goes longer. He has a longer relationship with Bjorn than I do. So I put a lot of weight into what Lucas says of evaluating the situation. It's also the case that Bjorn's not here. And so we kind of need that. It's nice to have Lucas here as the kind of as the voice of Bjorn in these discussions. The other thing I'll say though is we, even though the core interface for this is built into the PCI core, you can't remove it. You can remove the bottom half. So there's a top half interface layer that's talking to the PCI core, and then there's this bottom half that's actually the low level driver that's talking to SEV-TIO or COVE-IO or Intel TDX Connect, like that low level driver that can be modular, because it has to be, because on Intel TDX Connect, like the interface to even talk to the TSM is not even loaded until KVM modules loaded. On SEV-TIO, the driver that runs and talks to the TSM is a PCI driver, so you can't have the PCI core needs to enumerate the device, load its driver before you even realize that there's a TSM on the platform. So even though it's in the PCI core, it's still going to have dynamic functionality that can be loaded, unloaded, and pops up at runtime and responds to hot plug events and all these good things. So we can kind of have our cake and eat it too. One of the things that happened recently that gave me confidence that this can happen is that Greg KH took a patch set recently that allows for this is a low level detail of Linux, but there's something called sysfs group attributes, and you can append as many groups as you want to a device object in Linux, and you can give those groups names, like a name, and then that name will show up as a directory entry in Linux. The new feature he took was being able to dynamically hide that entire group if the functionality is not present, and then bring it back when it does show up. We've always had the ability to do that for individual attributes, but not entire directories at once. And so the plan here is that when the TSM driver, low-level driver loads, it will come back and refresh all of these TSM group attributes on all PCI devices that do support it. And the nice thing about that is that event is published to user space. The event of a TSM driver binding the event of in addition to an event of when a PCI device arrived, there's also an event for drivers binding. And so when the TSM driver loads and attaches, it will create a generic device object representing the platform TSM. That will be the cross-vendor generic object. And because we have that, we can now write policy around that event. So what I want to use that for is writing the policy around which devices get to have a selective stream and which don't, because I know, at least on the platforms I'm looking at, there's a limited number of streams. Like you can get into a situation where you have more devices that can support a selective IDE stream than you have ones available, and so there's going to need to be some policy engine somewhere to make that choice. And the policy in Linux almost always means user space. Like kernel is mechanism, user space is policy. And so I know some people have been concerned, like, oh, if it's a sysfs, so we have a sysfs attribute that says in this TSM directory that's going to pop up, there's going to be an attribute that says connect, and all you do is write one to that to connect your device. And people are like, well, who's going to write that? Do I need to have like my virt manager do it when I'm assigning a device? And the expectation for me is no. That's going to be a static policy. Probably the default policy is, because in the beginning we're probably only going to have that one special device that does this. So you can just have a default policy of, if it supports it, connect it, and you're probably not going to run out of selector streams. But when we do get to that point where the market is more mature, and we have competing concerns, that TSM arrival event can have we can attach arbitrary scripts to say, connect that one, don't connect that one, and so by the time you start to define your VM, everything's already connected, and so I think that works. That should work for any late arriving TSM, and you should basically expect that you have all your devices connected by the time you're starting, but by the time that platform is starting to define VMs. The other reason to be in the core also is that connect state really is you can really think of it like a link state. It's kind of something that you want to always, like, once you've decided you want this device to be connected, you probably want it to always be connected, and that means connected through events like reset. And because we're in the PCI core, now we can integrate with the reset handler the same way that Lucas has plugged into the reset handlers to re-authenticate automatically on reset. We can reconnect automatically on reset. So this is another benefit of being in the PCI core. Now, the discussion I wanted to review with this forum, and now that Lucas is here, is what is the relationship between native authentication and TSM authentication? And I had a kind of complicated proposal in the first round, and Lucas was like, that's too complicated. Why can't we just have it be the case that so right now Lucas has a authenticated attribute that just pops up next to a device if CMA has authenticated it, and the CMA policy is authenticate everything. If you have it, like, why not? And you can view the authenticated state in that attribute, and you can write anything to that attribute to cause re-authentication. When the TSM comes along, I want it to depend on the device already being natively authenticated. The reason for that is that it kind of keeps everybody honest that Linux ecosystem has access to certificates and all the collateral it needs to authenticate devices. We don't end up in a situation where, like, oh, Linux, no, you can't authenticate it. You only these few host vendors that have been blessed get the certificates, or something like that. Like it also is nice to have comparative authentication policies. We've already seen cases where, like, Lucas has noticed this change about whether device certificates should populate the subject alternative name, and on the Linux side, like, we want that so we can identify devices, and we've seen TSMs that don't. So, like, having that dual implementation is also just more robust in terms of saying, oh, like, why do you authenticate and you don't? So we can have that. But before I keep going on what this authenticated attribute, did you want to say a bit more, Lucas, about subject alternative name in this forum? I guess I'm trying to think if this is confidential information or not. I don't think it is. Like, I think the SPDM spec talks about the subject alternative name.
Yeah.
Actually.
Yeah. So there is recently, about a month ago, a new version of the PCIe spec was published, and that new version is 6.2. And there is a CMA ECN which was incorporated into the 6.2 spec, and there were some useful changes, and there was also one not so useful change. And the not so useful change is that they removed spec language for the subject alternative name. So what's that? So if a device authenticates, there is hardware identity baked into the certificate. That's like when you're connecting to a web server with HTTPS. If you look at the certificate, there is a subject alternative name which contains the domain name for the remote host. And for PCI devices, it's exactly the same. It's just that the subject alternative name doesn't encode a domain name, but instead the vendor ID, device serial number, and several other, some more data like that. And the idea is that you can, so if one certificate manages to, so one certificate should not be able to misappropriate a certificate from a different device. And so let's say you manage to exfiltrate the private key and the certificate from a device, and you're using that to masquerade as that device. And the ability to authenticate the subject alternative name is basically a mitigation against this misappropriation of certificates. So in particular, you cannot bind an arbitrary driver to a device. You can only bind a driver to the device which has a particular device ID and vendor ID. And that's because the other device which misappropriated the certificate, it may misappropriate the certificate, but it cannot change the device ID without the certificate becoming invalid. So that requirement to have hardware identity in the certificate still remains in the 6.2 spec. So the spec still says you have to include hardware identity in the certificate, but it no longer specifies how to do that. And in 6.1, we had very specific spec language which explained how to encode all that information in the subject alternative name. The reason for this spec change is that some people at the PCI SIG were unhappy.
I think the reasons are I think our PCI SIG confidential, like the
okay. Oh, right. Good point. Sorry about that. Yeah, whatever. So they made this change, and the problem is people have begun creating products which adhere to the spec language in the 6.1 spec. And we cannot easily change that. And so basically what we're going to do is we will push through with what we have. We will continue to validate the subject alternative name according to what's in the 6.1 spec. And we will basically ignore that this more specific language was dropped from 6.2 specification. So it's something to keep in mind. Yeah, sorry, go ahead.
But I would assume we could probably do a debug mode. Actually, but before I go into that, David, I see your hand up.
Yeah, thanks. I want to go back, I guess, Dan, to the statement you had made just before this about authentication. Can you explain more what you mean by authentication in that context? Because there's the fetching of certificates, right, and measurements, and then there's the sort of approval of those and deciding that they're acceptable. Right. So are you referring to just the first one?
Yeah, just the first one, because native CMA has no acceptance. It's just, did I have the certificates installed that I needed to validate the device certificates, and that's it.
Okay, and so your point is that the host, so like Linux would be required to get the certificates itself, in addition to the TSM getting the certificates. Is that right?
That's the idea, that we have the ecosystem in place where people are like, oh, we make sure that we have the ability to validate certificates from the Linux side as well. But I will say also,
you just said validate, and so that's getting to the second part, right? Because I feel like validate implies some sort of decision about whether it's acceptable or not.
Yeah, sorry, I use the term validate not in the security sense. I'm still learning my security trigger words. So, yeah, no. So it just means like just certificate authentication.
So I mean, the TSM does not do that, right? The TSM gets these certificates and it will pass them to the guest, and the guest will authenticate them and validate them. Okay.
But
Right.
for the native case, it's a little different. For the native case, we have a keyring in the kernel, and you can add trusted root certificates to that keyring, and the kernel will make sure that the device certificate chain is signed by one of those trusted root certificates. So that's for the native case. But you're right, for the TSM-driven case, that decision is up to the guest.
Right. So that's where I'm not quite sure I see the value in the dependency that we're bringing up. I might be missing something.
I think well, two things. One, I think this itself is a policy decision, and that that we would either be a debug or it'd be a formal policy. I've decided about whether you require this. Like certainly there will be a debug mode opt out to say no, just bypass that authentication and go straight to TSM based stuff. But the benefit I see is less is more purely a Linux benefit, that Linux ecosystem is not cut out from being able to authenticate devices, and so that people can write policy like, I want to gain some confidence in the provenance of this device before I even start the whole binding it to a guest flow. So it lets you write some native policy before you even start this process, because like maybe you don't want to. At least I've heard this feedback about maybe want to have a policy about valuing that first.
So
okay, yeah, I guess if it's optional, that seems fine.
Yeah, but whether it's go ahead, Lucas.
Thanks. So if you do not populate the keyring in the kernel with a trusted root certificate, the only side effect will be that you will get a message in DMESC with info severity that there was no trusted root certificate. So that's with info severity. It's not even an error. You just get an informational message in DMESC. That's the only thing that you get. So I don't see how that could somehow be a downside to anyone.
Yeah, I mean, yeah, the upside is Linux included. I mean, the downside is at least maybe from a hardware validation standpoint of like, hey, I didn't like, especially in the early days, if you're getting your Linux distribution from upstream and your certificates aren't published yet. Now you have to, and like a hardware vendor knows how to deploy their certificates into their TSM. They may not necessarily know how to deploy them into Linux, but that's certainly where I think the opt out is useful to say, like, you know what, that's a production Linux policy thing. I'm just trying to validate that my TSM can talk to my device, so turn that off locally. So we'll definitely have that release valve. The open question is whether that release valve is always there, versus only in debug builds. But this also will be a question for Linux distributions to solve themselves. Like, this isn't, the kernel probably doesn't need to decide this for everybody. Basically, contact your Linux distribution to pick this policy. But we'll have a kernel mechanism for the distribution policy to be like, hey, all you vendors need to send your certificates to us so we can distribute this in Linux, and you'll have other distributions that make the other decision, like, go ahead, TSMs, you can do it all by yourselves. So we'll have those options. But circling back to what this looks like in Linux is that device supports CMA. Lucas's patches authenticate that device. and then there's this authenticated attribute that says, yep, authenticated. When the TSM infrastructure loads, it will, and the UDEV policy says, on device arrival, connect this device. The plan is for that event to tear down CMA and bring up TSM, but as far as the authenticated attribute is concerned, it will still say authenticated. It'll just be being provided by the TSM code instead of the CMA code. So you don't have to go looking in multiple places to see for devices authenticated. But you said something. You said something, David, about the guest. Only the guest cares about the certificates. Like we still need to set up. We're still setting up SPDM on the host side, right? So we're still doing the authentication step.
Well, you can. But you don't have to.
But don't we? But we'd have to.
The TSM sets up the SPDM session.
Right. But it's doing that at connect time, and part of that is mutual. Well, maybe not mutual. Is authentication, right? Of setting up the SPDM session, because you need to have a secure session established anyway to start programming IDE keys.
Right, but that's my understanding. That's between the TSM and the DSM.
Yeah.
The host OS does not participate in that, other than as just a conduit.
Correct. Right, but in terms of like reflecting, like so as far as the OS is concerned, all it sees is connect and success or fail. It doesn't know what's happening behind the scenes. But in terms of reflecting, like, so if we have policy, because we're going to have CMA and people are going to have policy around authentication, we basically don't want to confuse any user space software that just cares about that authenticated bit. They don't care about validating or accepting, or all they care about is that authentication piece. They won't be confused when this device switches modes from native to TSM connected. They'll just the sysfs will just won't even blink. It'll just say, yep, it's still authenticated. So we can have that continuity. And then go ahead. Somebody's gonna.
Yeah, no, I was just trying to learn words myself here. So when you're saying native, I'm reading that as when the host OS is talking, as opposed to the TSM or the guest OS.
Correct. Yeah. Native is Linux as the initiator of this.
Okay.
So yeah. So does that make sense? Like at least I've convinced myself that this takeover is possible, and we can maintain this continuity across native CMA. I think this also potentially helps Bjorn understand that these things are how the attributes are related and how they work together, because that whole takeover mechanism is also in the PCI core.
So just to clarify that, if a device only supports one SPDM session, then when you do the TSM connect, then it's going to destroy the native host session, and that's acceptable?
Yep.
Okay, good.
Yeah, because you're explicitly setting policy of like, I want to switch, I want to connect, and that and the implication is destroying the other session. And then we disconnect it. Yeah, it will re-authenticate, switch the session back. But yeah, it's a cutover. So yeah, it's kind of not fair because Alexi's not here. This so I mean so now we have this meeting every 2 weeks. I'll circle back to you, Z. Every 2 weeks, and so this is going to be this time slot. No more doodle polls and no more scheduling. This is the nice thing about being in the CCC. But this meeting, this time slot is monthly, and the Australia China friendly time is also monthly, but offset 2 weeks. So every 2 weeks we'll have this meeting. if you missed one, we have YouTube recordings to catch up. Go ahead, Z.
So you're saying like when you switch from the the native mode to the TSM mode, so you have to reconstruct the SPDM. I heard something like that. So if that's necessary, I would just say, can we carry over it?
No, you can't because the session can only have one owner, and the session also wants to install its own
I see.
keys.
I see. So it's the owner, right? The owner is different then. Yeah. So we have to reconstruct it in that case.
Yeah. I mean, but the reconstruction is like as far as the TSM is concerned, it's like it doesn't really care that there was anything else there before. It just starts making a new session and off it goes.
Yeah, I see. Yeah, I see. So another question is like, we see like there's a lot of things happening in the mailing list right now. So what I was thinking is like, do you have maybe a backlog list? Like, because currently I think you are working on the attestation and also these TSM patches, right? So it would be nice if you can have a backlog so we can prepare to like, what kind of discussions we need in which items when you are going there. I was just thinking. Yeah.
Okay. Yeah, I can try to make something a bit more transparent there. I mean, but the basic idea is get this PCI thing settled before we start talking about the KVM integration and the GHCI. I mean, there's probably more work back there, but like nothing can happen until we get past this first kind of common infrastructure piece. I think the exit criteria, success criteria here is, I mean, honestly, I feel like these two kind of POC implementations that I know about, they're like, oh, that's interesting, but haven't got that kind of actual porting over and
I see.
adopting
it.
Yeah,
I understand.
But that's what we're working towards, and so but basically just working through the feedback, and we've already changed some things like to based on people's review and comfort levels, like Alexi's feedback about he really wants a lot of this to be modular so he can just for debug and swapping things out, and so that led to the design of a small core, but still allowing modular. So that was good feedback, and then the CMA discussion has been useful for like sanity checking our SysFS interface. Oh, that's the other thing. So the other reason to interface with CMA. Actually, any other questions before I kind of switch topics?
Oh, no, it's fine. Okay. Yeah, because the flow looks good to me actually currently.
Okay.
Yeah.
Okay.
Yeah.
So the other kind of pathfinding thing that the CMA stuff does for us is that CMA is going to need a user ABI for conveying measurements to user space, and we probably don't need to reinvent that we shouldn't reinvent that for the TSM case. What that means probably in the guest side, when the guest is needing to look at measurements and do measurement validation, that the interface, the same SysFS attributes that the same names at least and the same semantics of those things that are there for the CMA side, like in SysFS /PCI/ whatever measurements, that we probably want to share that with the TSM side. So we only write one ABI once, and that's useful for us on the TSM side that we have the CMA thing kind of path clearing that ABI discussion. Actually, that brings up a good point. So somebody talked. Actually, go ahead, Gobi.
A couple of questions, Dan. One, for the attestation topic that ABJ just talked about, there could be nonce coming from the user mode. Is that what you have in mind as well for the ABI?
That is what I was just about to talk about. Yeah.
Okay.
The question I had.
Sure. The second one for the when you transfer the control of SPDM requester from the native to the TSM, can there be device specific steps taken in between? For example, can we introduce some sort of reset?
Yeah, I mean, so the connect policy, I want it to be, it's going to be user space policy. So yeah, you could certainly in this UDEV script that's going to say, hey, this device arrived and the TSM attached to it. Do you want what do you want to do? Do you want to connect it or not? You could definitely do whatever you want in that script, in that policy, and say, yeah, do resets whatever you want, and then do the connect to establish things.
Okay, and who's going to provide this policy? Is the device driver that's going to provide the policy, or
this is going to be this will ship in the Linux distribution. Probably a default policy will ship in Linux distribution, but any kind of vendor utility or vendor driver could deploy its own policy to override. If that makes sense. So if somebody had this is just general Linux sysfs UDEV. If you install a package and you want to deploy UDEV rule, you can, and you can override the default UDEV rules.
Okay. Thanks.
Yeah, but your question about nonces reminded me of a request that Lucas had at Plumbers, which was for the measurements to. I think we're back on. Need mute on Gobi.
Is it better now? Sorry.
Okay. Yeah, is wanting to have a mechanism for be able to validate the kind of the freshness of their measurements, and the audience was asking Lucas about how are you going to include a nonce in this measurement collection flow, and so that was an open question I had about the about this connect flow and measurement collection is, do we need an ABI for passing a nonce, and where does that ABI live? Because I think there's two options. I think there's you can trust the TSM to just provide the nonce and see the result of that. But what I don't know is if that also needs to be supplemented with at least from the Plumber discussion about what people want to do with native CMA, it sounds like people also want to pass a nonce somehow. Lucas, go ahead.
Yeah. So my opinion is that it doesn't make sense. And also it sounded to me like that's sort of optional. So what I do understand is James Bottomley's request that user space should be able to verify that the kernel validated signatures correctly. So the kernel needs to provide proof that verification was done correctly. That's fine. But providing the nonce from user space to the kernel or to the TSM sounds, it's actually, I think it is dangerous, because what the kernel does is it just uses random data, and that's fine because it sort of guarantees that the nonce is always fresh. It's always a different nonce. And if user space were allowed to provide a nonce, who guarantees that user space provides enough entropy? So it sounds kind of dangerous to me, and I don't know. So I'm not a fan of that idea, and I tend to leave that out of the next version of my patch set.
Yeah, I think in the case
of one question.
Sorry.
On Lucas's point, when you said kernel, Lucas, you meant like the guest kernel, right?
So I am working on this patch set for native CMA. I can probably provide a link to it in the chat. The last version that I submitted to the mailing list, that was in late September, and I'm constantly working on it. I have a development branch on GitHub, so that's what I'm referring to.
Right. generation that you were mentioning, you were referring to the host kernel then, not the guest kernel.
Yeah, correct.
Okay.
Yes.
But
So in
but
principle,
when the device
go
is
ahead.
being presented to the guest, wouldn't the guest kernel or the guest user space need to do the nonce generation? It can't rely on the host kernel to do the nonce generation, right? For like the whatever we call the call to from the guest side to get device measurements.
Right. So it would, in principle, be possible that the guest also performs CMA on its own behalf and talks directly to the device. And all the host kernel would have to do is emulate the DOE register accesses. That would indeed allow the guest to do that. But so I envisioned that the guest is actually empowered to do that. And I included one patch in the last version of my series, which lets the guest perform CMA once a device is passed through. But it seems that nobody is interested in that functionality. Everyone wants to use the TSM once the device is passed through to the guest.
Yeah, yeah. I'll expand on that, but Gobi had his hand up. Go ahead, Gobi.
Sure. I just want to clarify when I said nonce is coming from the user mode, it's not the user mode that's actually creating entropy. It could be coming from the remote entity, so remote relaying party. The user mode just could be a pass through that's passing the nonce to the device or to the TSM.
Yeah, and that dovetails into why guest-driven authentication is not what anybody wants is because these environments, they want to attest the entire provenance of the entire VM, and the only thing that can do that is the TSM, and yeah, and if we have this remote relying party, they also want to that is the thing that's going to attest the entire thing, and that's why it probably wants to provide its own nonce to say like, hey, are these measurements from today, along with the attestation report from the VM, along with all of these other things, and then bring it all together and say, yes, I can deploy seekers to this thing. And so yeah, so that's probably why you're seeing the kind of the cold reception on guest authentications, because that's a very small part of the attestation flow of the whole thing. So yeah, I don't think we're going to solve this question in the last minute here, but I do think I'm still trying to think about how to incorporate that. That seems like just good security practices, that the thing that's going to remotely verify the entire report it should be able to provide its own nonce. But I just but that's probably going to be step 2 when, like, after we get through this basic kind of connect flow and get that upstream, then we can circle back to, okay, what does it mean on the guest side for measurements and measurement freshness and that kind of thing. So I had some other topics around how do we enumerate device capabilities in the guest. I think I'll want to save that for the next call. Actually, Mark, go ahead before we at the
Oh, I
end
just
here.
had a sort of a wrap-up comment. I've been following. I have worked on Windows internals for many years, so I have an interest in this. But I have an sort of a broader thing that I want to make sure that the SIG can answer.
Okay.
If an internal entity wants to attest a device, and device is disaggregated, so it has network, storage cards, GPUs, whatever. So basically the subject of what we're talking about here. I would like to understand how this interacts with governance, which means how do I know that I can trust this device collectively with code? And how does this work with how attestation policy is managed, how devices are upgraded? Right. So if we're, going to do any sort of like live upgrade on things, but effectively, I understand. I want to understand the end to end, and I would love the SIG to be able to answer that.
Okay. Yeah, I definitely think that we'll get there at the get there as we start getting into the guest.
It would just really suck if we were to design a bunch of things and then when it came to how is this integrating, finding out that there was some sort of a missing thing.
Oh yeah, yeah. That's why it's good to talk. Okay,
okay. Thank you. That's all. That's all for now.
Good deal. But thank you. I mean, thank you everybody for your participation today. I think these sessions are useful. Yeah, point people at the recordings when they come out, and we will see you at the next one, which is in 2 weeks in the Australia China friendly time. I think it's a Thursday evening Pacific time in 2 weeks. Other than that, thank you very much, and yeah, and feel free to reach out for any questions. Go from there.
Thanks, Dan.
Thank you, Dan.
Thanks. We'll see you later.
Thank you, folks. Yep. Bye.
Bye-bye.
And is the Thursday, it's the 21st or? Oh, looks like you don't. I'll catch up on it.